Okay, so I'm going to try to keep this to be a quick video, but this video is specifically to talk about how we apply numbers to grits and what those numbers actually mean when we're talking about various sharpening stones or abrasives, to be exact. So in modern stones, most stone companies apply a numerical value to grit, which is a generic term. Generally, it refers to how fine a stone is, meaning how smooth it is and how much it'll polish any kind of instrument as you abrade it or as you sharpen it. So the numbers correlate to a size of the abrasive, and that is actually just approximation. So what I mean by that, so I have 5 different stones out here. I have a vintage carborundum, which is a silicon carbide stone. It's from the early 1900s, late 1800s. They were made in Niagara Falls. They're some of the first commercially manufactured synthetic sharpening stones. I have an American-made DMT diamond plate. I have a Shapton Japanese-made synthetic glass stone. The part that you actually sharpen in your instruments on, the actual abrasives, are not made of glass. Glass is just the plate that's used as a brace for the stone. And then I have 2 natural stones. I have a Belgian mined conical, which is actually a combination of a Belgian bluestone, which is the blue bottom portion, and the yellow portion is the conical layer, to be exact. And then I have a German Thuringian, which is also a natural hone. So these are only out because I want to say this is why you can't apply grit numbers and values to natural stones. So back before we had quality standards in manufacturing, we didn't have any kind of organizational or oversight to say, this is your standard for your abrasive. So if you claim this value, it should be equivalent to abrasive particles of a certain size or have some kind of numerical value and tolerance associated with it. So this carborundum is actually defined as fine. But what does that mean? Well, it means nothing. It just means that in relation to other stones they made, this stone is smoother, the particles are smaller, and it's more dense, and it's going to get a higher polish than what they consider a coarse stone. This is actually why I really like these Shaptons. So Shaptons give you a grit number, which actually is mesh. And they also tell you the size, which is an average of the particles, the abrasive particles that are in the stone itself. DMT is an American company. They use the same system as Japan, but their 8,000 grit stones, or what they call an 8,000 grit or an 8,000 mesh, to be precise, stone, is not equivalent in particle size to the Shaptons, even though they claim they're using JIS, which is the Japanese Institute of Standardization, standards. And they're both correct under JIS. But how can that be? So Shapton says our 8,000 mesh stones have particulates, abrasive particles of 1.84 micron. For those that don't know, micron is shorthand for micrometer. That's just the metric unit, 1,000th of a meter. We don't have in an American system an equivalent value measuring size as a unit of measure that we can apply to that, since we would say it's actually a fraction of an inch. So it's much easier for even American-made companies to standardize the size that they're using based on the international system and using meters, in this case, micrometers. So an 8,000 grit DMT, or an 8,000 mesh DMT, claims to have particles that are approximately 3 micron in size. Now that's almost double the size of what Shapton claims. So in the equivalent Shapton stone, an 8,000 grit DMT would be about a 5,000 grit or 4,000 grit Shapton. And JIS says both of those are correct. But how can that be? It's actually because JIS does not say that in order to be 8,000 mesh, your particles must be of a certain size. There's no exact size. What 8,000 mesh actually means is mesh is a unit of measure, and it's related to sieve trays. So sieve trays, if you don't know, are basically big filters that you shake the abrasive particles through, and it filters out the bigger particles from the smaller particles. So the way that you apply that standard is Japan says that the number of wires in your sieve tray in a 1-inch linear fashion is the number that you assign your mesh. So in this particular picture, starting here at 0, you would say 1, 2, 3, 4, 5, 6, 7, 8. This is 8 mesh. Now notice it's 8 in this direction, 8 in this direction. So it's not a square inch, it's a linear inch. So 25.44 millimeters. So the way that Norton and DMT justifies by saying that our 8,000 mesh stone has particles of 3 microns and JIS says that's acceptable is they simply take 25,400 micrometers, divided by 8,000, and it's approximately equal to 3. They're saying if they lined up 8,000 of their particles in 1 inch, that they'd be about 3 microns in size. So JIS says that's fine because the standard for mesh does not actually apply to the particles themselves. What it actually applies to is the tray used to separate out those, or the filter used to separate out those particles. Shapton, on the other hand, says, well, that's not really the intent of how that was meant to be used. They actually use the formula for mesh, saying that if you have a cross-section of wires in your sieve tray and particles that are going to fit through this hole at 8,000 mesh, based on a standard diameter size of the wire used to create that mesh, or the fabric, or whatever the case may be, are on average 1.84 micron, meaning they can be smaller or they can be bigger based on how big this opening is. So based on how you apply the standard is how you can claim different sizes of particles and still have the same mesh value assigned to them. And JIS says, yes, that's acceptable. So that's kind of a short video on why Norton and DMT assign different particles sizes versus Shapton under the same standard, and it's acceptable. It's also why you can't apply numbers to natural stones, because there's no way to know how big these particles are in here. You know, every stone is different. They can be spread out different. There's no quality standards for natural stones. It's just how well they polish. So the reason that the higher mesh or the higher grit gets more expensive, especially in these Japanese stones, is because they have very high quality standards. I could say that for a fact. I work in quality in pharmaceuticals, and Japan is crazy hard to get anything through. It's very hard to get particles that small on the micro scale, because again, to put that in perspective, there's 25,400 microns in 1 inch across this stone. Just 1 inch. So I can go into more details. Does that mean the smaller the particles, the better the stone? It does not. Because actually it's how well that the particles are dispersed throughout the stone. I mean, you could have very poor quality standards, and even though you're using very small particles, you might have blank spaces in between. The shape of the abrasive makes a big difference. So rounded and squared abrasives are generally smoother. Anything with jagged edges is going to cut and leave a very aggressive scratch pattern. The way they check the size or the shape of the particulate, especially when it's that small and it's a very super fine powder, is they measure the density of the mass. So they have a known volume container. They put it on a scale, and they pour the particulate within the known volume container. And then based on how heavy that is, it's going to tell them the shape. So square particles, round particles will pack together more closely. It'll be more dense, it'll be heavier. If they're odd shaped, they're not going to line up right. They're not going to fill up as much of the empty space. And it's going to be lighter. How they know the exact size of the particle is a couple different ways to use it. They can apply Stokes' law, and they can do either what's called sedimentation, where they measure any viscous fluid, how long that it takes the particles to, fall through the fluid based on resistance and viscosity. They can run an electrical charge through it, measure it that way. There's a couple different standards they use. It all depends on the individual company. So, again, I know that there's a question out there of how can Norton and DMT claim 8,000 grit versus Japanese companies. And again, it's all on how you apply that unit of measure, because that unit of measure is not 8,000 grit, is not a unit of measure for the abrasive itself. It's actually a unit of measure for the